Hello everyone, so this is my notebook for Kaggle assignment 2. Let's start. So importing data, I imported it into train data, test data and submission, although we don't need submission. Then importing modules. So all the necessary modules which I have used in the notebook are imported here. There's train data.had, we have these columns and booking status is the target feature we have. First task was identifying data type of different columns. So we used train data.dtypes. We have integer, object and float data types here. Second was present descriptive statistics of numerical columns. So I used dot describe for this, and we got count, mean, standard deviation mean, then median of the columns we had. Now I generated some new columns to make good predictions. So the new columns are okay. First of all, I just separated the target feature, that is booking status, to Y, and I dropped it from train data, and along with I dropped the ID because ID we don't need it while we are predicting, and similarly from the test data I dropped the ID. Now I created a new column combining adult and children, that is total number of guests, then total nights is total weekends plus weekdays. Then in the lead time category, the lead time we converted the lead time column, which was, if we see lead time is float, we converted it into category for better output. Then we converted into last minute. If our bins is from 0 or -1 to 7, we convert it into last minute. Then 7 to 30 short, 30 to 90 medium, 90 to 200 long, and 200 to 500 very long. So lead time was the waiting time between the booking and the visit in the hotel. Then we identify and handling missing values. We have missing values in room time, lead time, price, and lead time category. These are the column we have missing values. Now how to handle that? So I used simple impute. For room time I used strategy most frequent, and for lead time and price I used strategy mean. Fourth is identify and handle duplicates. So we don't have any duplicates rows in this data set. Fifth, identify and handle outliers. If we see here, we have few outliers in lead time, in price, request, repeat, and adult. So we don't have much outliers. We can see the outliers is in between the range of 500, 600, and 700. So we don't have much outlier. Now present at least 3 visualization, provide insight for the same. Okay, so first visualization is for room count frequency. Room type 1 has maximum frequency, room type 4 has frequency around 5000, then all have around 50 frequency, 6, 2, 5, 7, and 3. Now frequency of male count, we can see 76.7% people choose male plan 1 and 14% are not selected. They didn't selected a male type. 9.2 selected male plan 2 and male plan 3 was not selected by anyone. Now frequency of segment count. So online has maximum frequency, then offline, then corporate, complementary, and aviation. Frequency of repeat count. So this tells us that how many new customers we got and how many old customers have booked again. So maximum are the new customers, very few are the repeated one. Then scale numerical features and encode categorical features. So for numerical features are this, categorical features are this, and we use column transformer. For numerical features we are using standard scalar, and for categorical one hot encoding. After encoding we got 577 columns, and before encoding we had only 15 columns. So we have a lot of categorical data in this data set. 8 is model building part, and we split the data into xtrain, xtest, ytrain, and ytest using train data which we have already imputed and transformed, that is we have applied the one hot encoding and standard scalar. Now our first model is logistic regression, and for that we got accuracy of 0.806 with max iteration 200. Model 2 is decision tree classifier. We got accuracy of 0.8526. And model 3 is extra tree classifier. We got accuracy of 0.865. Then model 4 was random forest classifier. We got accuracy of 0.877, which is highest. Now then model 5 is hist gradient boosting classifier, in which the accuracy I got is 0.609. And model 6 is key neighbor classifier, and the accuracy I got is 0.831, which is I think the lowest, no, second lowest. Lowest was in logistic regression. Then model 7 is XGB classifier, in which the accuracy is 0.864. Now ninth is hypertuning. So model 1 for hypertuning is extra-T classifier with parameter and estimator, and the extra-T accuracy we got is 0.866, which is slight increase with zero point 0.1. Then model 2 was XGB classifier. I used parameters and estimator, maximum depth and learning rate, and the accuracy is 0.86, learning rate 0.2, max depth 7, and estimator is 200. These are the best parameter after hypertuning. Then model 3 of hypertuning is logistic regression, and iteration is 1000. Okay, so I used C and solver, and iteration is 1000, so I got the accuracy of 0.81205. Now 10th is best model performance. XGB classifier is performing good in the test data set with an estimator of 1000 and max depth 14. It is not overfitting, it is actually working good. Usually when max depth is 14, it overfits the model, but in our case it is working quite well. The max score is 0.88. That's all. Thank you.